I'm Anil Kumar. Welcome to my series on pre-calculus. We are trying to learn few techniques which should help us to understand calculus. Now this video is very good for students who are going to high school or seeking admission to first year university. We have 6 equations to solve, all seemingly different types, but we have a common base here. That is, we'll use the technique of factoring, solving quadratic equations. We can say quadratic form of equations. And some of these equations involve radicals and also logarithms. Now, that means we have restrictions, so we could have extraneous roots. That really means that you need to check your solution. Now keep these things in mind when you solve these equations. I'd like you to pause the video, solve them, and then look into my solutions. Kind of a review of what you have been doing. Hope that makes sense. Now what kind of restrictions you have to look for? Clearly square root x, for example. That means x should be greater than or equal to 0. And if we have log of a function, let's say log a to the of b, we know that b should be greater than 0, right? So these are the restrictions which you need to look for. And of course, trigonometric functions have their own. So let's see how to solve these equations. So the equation here is x minus 3 square root x minus 4 equals to 0. Now, that really means that square root x should be greater than or equal to 0. To solve this equation, we can write some variable, let's say p, equals to square root of x. In that case, p square will be equal to x. Now, if I make that substitution, the equation changes to quadratic equation, right? So, replacing x with p square, we get p square minus 3p minus 4 equals to 0, correct? So this is a very simple quadratic equation to solve. We'll do product and sum to factor. 4 times 1 gives you 4, negative 4 will give me minus 3. So p minus 4 times p plus 1 equals to 0. Now that will give us two solutions. One of them is p equals to 4. The other one is p equal to minus 1. Now remember, p square is x and p square root x. So let's make this substitution, correct? So p equals to 4 means square root x equals to 4, right? So we could write this as square root x equal to 4. And p equals to minus 1 means that square root x equal to minus 1. Clearly, square root is always greater than or equal to 0. It is never negative. So this is not valid. So that is what we call extraneous root, right? So this is extraneous root. Square root x equals to 4 actually gives us two solutions. When we square both sides, we get x equals to 4 square, which is 16, correct? So we do get a solution which is 16 for us. So our answer here is x equals to 16. Now it's always a good practice to check your solution. Now I'm just showing it here for one of these equations. For rest, I think you should be trying it on your own. So we get what? We get 16 minus 3 square root 16 minus 4 equals to 0. That gives us 16 minus 3 times 4 minus 4 equals to 0. We have to see whether it works or not, correct? So we have 16 minus 12 minus 4, which is equals to 0, is true. Right? So we get 0 equals to 0. So that is how you have to do these equations and follow all the steps. Now let's take up the next equation. This time we have a radical equation, 2x minus 1 to the power of 2 over 3 plus 2 times 2x minus 1 to the power of 1 over 3 equals to 3. We can always write this equation in quadratic form by making a very simple substitution. So we can say let 2x minus 1 be to the power of 1 over 3 be equal to some variable, let us say y. Now in that case, what will the first term be, which is 2x minus 1 to the power of 2 over 3. Now this is square of that, correct? So that would be y square. So let's make this substitution here, and then we get our equation, which is y square. This becomes y square plus 2y equals to 3. Bringing 3 to the left, we can solve this quadratic equation very easily. Minus 3 equals to 0. Now you factor y 3 times 1 and plus 3, correct? So y plus 3 times minus 1, right? Equals to 0. So that gives you two solutions. One is y equals to minus 3. The other one is y equal to 1. But what is y equal to? Y is all this, 2x minus 1 to the power of 1 over 3, correct? So we could replace, now cube root could have negative and positives. Now let's see. So if I replace y with 2x minus 3, I get 2x minus 1 to the power of 1 over 3 equal to minus 3. And on this side, I get 2x minus 1 to the power of 1 over 3 equal to 1. How to move forward? Now we should do cube both sides. Once we do the cube, we get rid of this radical, correct? So the next step is to cube both sides. So let me write down here. So now we'll cube both sides. And then solve it further. So the first equation will be 2x minus 1 equal to minus 3 whole cube, which is minus 27, correct? The second one will be 2x minus 1 equal to 1 cube, which is 1. So that is how you could get your solution. Now it's just a matter of solving for x from each of these. So for the first one, which is 2x minus 1 equal to minus 27, we get 2x equal to minus 27 plus, taking this minus 1 this side, plus 1 equals to minus 26. So x is equal to minus 26 over 2, which is minus 13, right? For the second equation, it is 2x minus 1 equal to 1. So that gives you 2x equal to 1 plus 1, which is 2. So that gives you x is equal to 2. So we have two solutions here. We can write down our answer, which is, in this case, minus 13 and 2. Now, well, I did a mistake. 2x equals to 2. So x is equals to 2 divided by 2. 2 divided by 2, which is 1. So the answer is minus 13 and 1, correct? So we get our solution here, and let me rewrite the answer here. The answer is x equals to minus 13 and x equals to 1, correct? So these are the solutions. So you can actually check the solutions. When you substitute 1 here, 2x minus 1 is 1, and 1 to the power of anything is 1. So 1 plus 2 is 3, correct? And when you substitute minus 13, then you get minus 26 minus 1 as minus 27. Cube root being minus 3 and square will make it positive 9. So positive 9 minus 6 will give you 3. So that works, correct? So that is how you could check the result. Now let's move on and take the next example, which is Again, a square root function. Square root of 2x minus 7 minus x equals to 2. Now to solve such equations, we could take x to the other side. So we get square root of 2x plus 7 equal to 2 plus x. And now we can square both sides. So when you square, you incorporate errors. Now here you should definitely check, correct? So we get 2x plus 7 equals to 2 plus x whole square. So that gives you 2x plus 7 equal to, let's expand it. So 4 plus 2 times 2ab, that is 4x plus x square. Let's bring all the terms together. We have x square on the right. So we'll keep 0 here. Take all these terms to the right. X square plus 4x minus 2x plus 4 minus 7. So we get 0 equals to x squared plus 2x. And that gives you minus 3. So again, we land with a quadratic equation which can easily be solved. So we have x squared plus 2x minus 3 equal to 0. Let's factor. 3 times 1, 3 positive. So x plus 3 times x minus 1 equal to 0. X could be equal to minus 3 or x equal to 1. Now here we have square root of 2x plus 7. Remember, there is a restriction. X has to be greater than minus 7 over 2, minus 7 over 2, right? Greater than minus 3.5. So it is within the domain. So yeah, so it is in domain, right? So we expect them to be correct. But let us check. So if you check, what do you get? If I substitute minus 3 here, we get square root of, let's say, let me write minus 3 times 2 this now. Okay, minus 3. So that gives you minus 6 plus 7, which is square root of 1, which is 1. And here, positive 4. Is it okay? So when you substitute minus 3 for x, this becomes positive. And the result is 5. It is not what you expect. It is not 2. Correct? Now we'll substitute 1 here. So if you substitute 1 here, we get 2 times 1 plus 7 minus 1. Let's check this one. So we get square root of 9 minus 1. And square root of 9 is 3. 3 minus 1 is 2. So that works. Therefore, our answer in this particular case is only x equal to 1. And this becomes extraneous rule. Do you get the idea? Right? So x equals to minus 3 is not the right answer. So the only answer here is x equal to 1. And this one is an extraneous rule. So in spite of being within a domain, it is not part of our solution. One of the reasons being that when you square here, at this stage, you incorporate errors. Since you make negative thing also positive. So I hope that makes sense, right? This time we are going to work with a trigonometric equation. The equation is 2 sin x tan x minus 2 sin x plus 1. There are 4 terms. We see kind of a pattern. We could factor and then solve. So in the first 2 terms, I could factor tan x. So if I factor tan x, I get 2 sin x minus 1. Here I could factor minus 1. We get 2 sin x minus 1. Since there is minus outside, I have to change the sign. Now 2 sin x minus 1 is a common factor. Within the brackets, we get tan x minus 1 equal to 0. Now for this equation to be true, either 2 sine x minus 1 equal to 0 or tan x minus 1 equal to 0, right? So we have two sets of solutions. So that gives you sine x equal to half, and this gives you tan x equal to 1. Now in such questions, you might have a domain, right? So, or you might have general solutions, right? So what I will do here is restrict the domain. So let's work in degrees for this example. So let's say the domain here is between 0 to 360 degrees, okay? In that case, what are my solutions? So when we say sine x equals to half, we are trying to say that sine is positive in these two quadrants, correct? So we are expecting solution in quadrant 1 or in quadrant 2. I hope you remember, all are positive here. Sine is positive, tan is positive in 3, cos in 4. Since we have a positive result, we have two solutions. Perfect. Second, let me remind you of our special triangles. So special triangle for half, the values is 2, 1 and square root 3, and this angle being 60 degrees. In that case, we get, and this angle being 30 degrees. Let me write here 30 degrees now. Sine is opposite over hypotenuse, so for 30 degrees, you get half, correct? So that means this is 30 degrees, and that is also acute angle, 30 degrees. So what are my two solutions? Well, two solutions should be x equal to, of course, 30 degrees. And here we have to write the principal angle, which is, let me use a different ink, which is 180 minus 30. So I hope that's a good reminder of what you have been doing, which is 150 degrees. So the other one is 150 degrees. So there are these two solutions. So I hope that is clear, right? Now let's look into tan x. For tan x, it is positive in these two quadrants. So we are looking for solutions in these two quadrants. And tan is positive 1 for 45 degrees. So the acute angle is 45 degrees. So the two solutions here are x equal to 45 degrees and 180 plus 45, right? So 225 degrees. So I hope that's a good reminder. That is how you have to solve. And so what is your answer? In your answer, you have to write all answers, which are x equal to 30 degrees, 45 degrees, then we have 150 degrees and 225 degrees. Does make sense to you, correct? So that is how you're going to solve trigonometric equations. I hope that makes sense. Let's move on and take up the next equation now. The solution of 9 to the power of x times 9 to the power of minus 3x equals to 27 is what? You can pause the video, answer this question, and then look into my suggestions. So let's try to solve it. So we have 9 to the power of x times 9 to the power of minus 3x equal to 27. Now, applying the laws of exponents, we need to add these exponents. So we get 9 to the power of x plus minus 3x, add them, equal to 27 could be written as power of 3 cubed. Now this gives you 9 to the power of minus 2x, right? Equal to 3 to the power of 3. Now since the base is 3 of the right side, we should convert this 9 also to the base of 3. So it becomes 3 squared. So 9 is 3 squared. So we can write this as 3 squared to the power of minus 2x equal to 3 cubed. Applying the power rule for the exponents, it could be written as 3 to the power of minus 4x which is equals to 3 cube. Now when the base is same, you can equate the exponent. So you get minus 4x equal to 3, and that gives you the answer, that is x is equal to 3 divided by 4 with a negative sign. So the option B is the right option. So I hope these steps are absolutely clear. Go through these steps once again. This is a very important question from many tests point of view, especially SAT. So we are almost at the end. Now let us see how to solve logarithmic equation. Now remember, in this particular equation we have a restriction. So let's begin by defining our restriction. So the restriction here is that this argument, which is x squared minus 3x plus 5, that has to be greater than 0. So that is kind of very important to understand. Okay, so that is the restriction which you have to work with, and whenever you find a solution, you have to check your solution. Okay, that's the first part. Now let's see how to solve it. To solve the equation, we could write it in exponential form. So to write exponential form, we could write this as 3 to the power of 2 is equal to all this, or x squared minus 3x plus 5 equal to 3 to the power of 2, which you know is 9. Let's bring 9 to the left side. We get x squared minus 3x plus 5 minus 9 equal to 0, which is x squared minus 3x minus 4 equal to 0. 4 times 1, negative 4 we are going to take since minus 3x, and we get x plus 1 equal to 0. That gives you two solutions. One is x equals to 4, the other one is x equal to minus 1. Now these are my two solutions. Now we need to check our answers for sure. So let's make a small check. So in this equation, which is log to the base 3, if I substitute 4, what do I get? I get 4 squared minus 3 times 4 plus 5, which is log to the base 3 of 16 minus 12 plus 5, which is log to the base 3 of 4 plus 5 is 9, correct? Which is log to the base 3 of 3 squared, which is equal to 2. Perfect, it works. Right? Now let's use minus 1 and then again check. Let me make a room here for the other check. So we get log to the base 3. We are using minus 1 now. So minus 1 square is 1. Minus 1 makes it positive. We get plus 3 plus 5, which is log to the base 3 of 4 plus 5 as 9, which is log to the base 3 of 3 square, which is same as 2. So it also works, correct? So both solutions are correct for us. Both work. So therefore, we say that our answer is 4 and minus 1. So that is how you're going to solve it. I hope that makes sense. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.